We're doing a little investigation into the effect that scale has on perimeter, area and volume. So if you get a shape like this and you increase its size, what happens to its perimeter and what happens to its area? If we were to double its dimensions, the rectangle will now be 6 centimetres long, 2 centimetres wide. Or if you tripled it, it would be 9 centimetres long and 6 centimetres wide. That should be a 4, shouldn't it? But what would happen to its perimeter and what would happen to its area? I'd like you to do some calculations in a moment to work out the perimeter and area of each of these, and in particular, then work out how many times did the perimeter increase when you doubled its dimensions and how many times did it increase when you tripled its dimensions. And what about its surface area? How many times did that increase under the scale factor increase of 2 and under the scale factor increase of 3? You can do the same thing with the circle. If we were to increase its size by a scale factor of 2, its dimensions increase by, so the radius will become 4 centimetres, or in this case, if you triple it, its radius becomes 6 centimetres. What happens to its perimeter and what happens to its area? You do the calculations. Well, I've done some calculations. I wonder how yours matched up with mine. This is what I found. I found that when I doubled the dimensions, the perimeter doubled. When I tripled dimensions, the perimeter tripled. But the areas were quite different. Doubling the dimensions brought about a 4 times increase in the area, or tripling them brought about a 9 times increase in area. I found exactly the same results worked for the circle. Doubling the perimeters increased with the scale factor. So in other words, doubling the scale factor, the perimeter, or circumference in the case of a circle, doubled. Tripling the dimensions, tripling the radius, brought about a triple in the perimeter. But the areas, a doubling of the radius, brought about a 4 times increase in area, or a tripling the radius brought back a 9 times increase in area. You see, the thing is that area doesn't increase simply with the scale factor. If you increase the dimensions of a shape by a scale factor, then its area increases with the square of the scale factor. When we doubled the dimensions, the area increased by 4 times because 2 squared is 4. Or when we did a scale factor increase of 3, the area increased by 9 times because 3 squared is 9. There's a question at the bottom of the page, and I've written a little summary for that. The perimeter of a plane figure increases with a scale factor increase in its dimensions, but its area increases with the square of the scale factor. If a shape is scaled by a factor of 1.5, its perimeter increases 1.5 times, but its area increases by a factor of 1.5 squared. That's 2.25 times. Okay, we're going to move on to a second example here over the page, and this time we're looking at solid shapes, and we're going to have a look at what happens to the total surface area and to the volume when you increase by a scale factor. So here we've got a cuboid or rectangular prism. We are firstly going to double its size, and then we're going to triple its size. What happens to the total surface area and to the volume in each case? Then I'd like to do the same thing with a sphere. I wonder if you can do some calculations now, and we'll come back and compare results. Okay, this is what I found. I found that the surface area increased when I doubled the dimensions of the shape. The surface area increased by 4 times. If I tripled the dimensions of the shape, the surface area increased by 9 times. Once again, we've got the same thing as with the plane figures. The surface area of the shape is increasing with the square of the scale factor. You double it, and 2 squared is 4. The surface area is 4 times as big. Or if you triple it, 3 squared is 9. So the surface area is 9 times the size of the original. Volume is quite different. I found that the volume of the enlarged shape under scale factor 2 was 8 times as big as the original. Or if I tripled the original dimensions, scale factor 3, the volume was 27 times as big. Exactly the same results occurred with the sphere. You see, surface area increases with the square of the scale factor, but volume increases with the cube of the scale factor. So if you have a scale factor of 2, the volume increases not 2 times, but 2 cubed times. 2 times 2 times 2. That's 8 times. Or, if you've got a scale factor of 3, the volume increases not 3 times, but 3 cubed. 3 times 3 times 3. 27 times. I've written a little summary at the bottom of the page. Can we just squeeze it in there? So, the total surface area increases with the square of the scale factor, but the volume increases with the cube of the scale factor.